All right, hello, fellow coders. Welcome to yet another live session with your man, Trevor Page. I'm just going to refresh my feed here in my own little app to make sure I can hear myself. Let's see if I can hear myself. And yes, indeed, I can. So that means my audio is working well. So basically what we're going to be talking about today is recursion in Java. But even more generally, recursion is not a topic that is just for Java. It is a topic that spans all programming languages. So the concepts here that I'm teaching, although they're going to be with Java syntax, these concepts can be applied to literally any programming language. And this was a question that was posted in the group by one of the followers, so that is what I'm doing. I'm going to be answering questions for him. And if you do have any other questions while I'm talking about recursion, feel free to ask them. I will check on my phone periodically to see if there are any questions, whether it's about recursion or whether it's about anything else related to programming, typically related to Java programming, because that is what I am good at. So, very good. Let me just check the comments here and let me turn myself down to make sure. I think I saw something happen there on the screen. I'm kind of far away from my thing. I don't see any comments yet, so that's all right. So let's go ahead and get started with an example of recursion. All right. Let me put my phone down here. So with recursion in Java, we are looking at methods that call themselves over and over again until they hit a sort of base case. So the first and most important rule, let me just see how high I can go here. Looks like I can go about that high. The first most important rule is you need a base case. Okay, so what I mean by base case is you need a situation in which the program will terminate when it's recursively calling itself over and over and over again. Because if you don't have a base case where the recursive algorithm can terminate, or rather, return something, you're going to be infinitely recursively calling itself over and over again. And what happens is your application will just crash. It'll just stop, and it'll say output an error in your console that will have a never-ending bunch of the same lines saying error here, error here, error here, whatever the error is, I forget. So it's just gonna output a bunch of errors. So make sure you have a base case with your recursion. And then the second rule is typically you need somewhere to start, right? Somewhere to start. So this is typically a starting case, if you will. So a place to start and a place to end are the most important things. And then, of course, the third rule is, it essentially needs to call itself, right? To call itself. It needs to be recursive. Those are essentially the three rules to writing a recursive method. So let's give an example. So the sort of hello world example when it comes to programming with recursion is typically factorials, right? So factorials comes from mathematics. So typically it's it's defined as n exclamation point is essentially a factorial. So for example, we'll be working on the case of 5 factorial. So 5 factorial actually equals 5 times 4 times 3 times 2 times 1 equals what, right? So basically what this does is it's essentially an algorithm where it's equal to, where n, is that where n is equal to n, or maybe not n, but result. So let's do something like r for result. Result is equal to n times n minus 1 is essentially the formula that we're going to be building out here. And I do have a comment here. He says, I'm a Java developer too. I'm always practicing algorithms and read a book on frameworks. What is the best routine to be a good programmer? So we'll get into that question a little bit once I've gone through my stuff here. I'm going to grab a drink. 1 second. Beautiful water. So the result here is going to be n times n minus 1, where, and actually, I shouldn't say n minus 1, it's n minus 1 essentially calling itself, right? So this is essentially what we're going to program in. So what the code will look like I said, you need a place to start, and you need a base case, and it needs to call itself. So the place to start, typically, I'm not going to write out the whole syntax, but you'll have like a public static void main. This is the place where you can start coding inside of your Java programs, right? So I won't write it all out, but you'll have a place to start. So we'll just say, let's see, how far back can I go? I can go pretty much this far. I'm trying to, make sure I have as much space as possible to write. So we'll say, whatever. We'll just say public. I'll just write it out. I'll just write it out kind of small. Static void main, just because this takes so much room to write string, and it's a double bracket arguments, right? That's sort of the starting point for our program. So essentially what we want to do here is we want to call a method. You want this method to be a recursive method. So you can call the method whatever you like. It could be called n, it could be called r, it could be called whatever the heck you like. I'm going to call it factorial because that sort of makes the most sense. So we'll call it factorial. So we'll have it call factorial. And then this is going to be the starting point, right? Where do you want to start? At what number do you want to start this entire process? Now I say number here, but the process in which it starts when it comes to generally speaking about recursion can be whatever. I mean, in this starting point, it's going to be a number, but perhaps you could be working with a string, perhaps you could be working with an array. Who knows, right? The recursive algorithm that you're writing is going to be specific to whatever problem you're trying to solve. Okay, maybe if I have time, I'll talk about a different recursive algorithm that I actually made in the real world to solve a real world problem on one of an old application that I built like 5 years ago. Like I said, if I have time, I can talk about that. If we do have time and I forget about it, please do let me know in the comments to remind me to talk about that. So, starting point. Well, over here we had said 5 factorial. So that's a fairly small enough number that we can digest fairly easily. So let's start with 5 factorial. So we'll say 5. And then we can sort of do this. So this is going to call a method called factorial. But in Java, there is no method called factorial. This is something that we just made up. So now we need to define what the factorial method actually does and what it means. So let me put a little end bracket there. So I'm going to create another, method. The method, it's going to have to be static because I have static here, but ignore the static keyword. I mean, this is just to make sure that it'll compile properly. Don't worry about the fact that it's static. But it will. We do need to, care about what it returns. So what will this return? Well, this is going to return a number. Okay, it's not going to return a string. It's not going to return an array. It's going to return a number, and that number is actually going to be pretty darn big because when it comes to factorials, we know that these numbers grow very fast. When it comes to mathematics, at least we should know that these numbers grow very fast. So instead of returning an integer, I'm actually going to return a long. Okay, that just means that I'm going to be able to get more data out of, more useful data out of this factorial. Because, like I said, the number's going to grow very big, very fast. So static long, we're going to call it factorial. Factorial. And then it's going to take something, right? It needs to take a parameter. What parameter does it take? It's going to take, most likely, a long. Well, I guess it doesn't actually have to have taken a long because the number here, we can't get it to be very high before this entire thing falls apart. So we actually probably don't need to take it along. We can probably just take it an integer. We'll call it n. Okay? Because I can tell you, I just tested this on my own computer. This only goes up to 25. Okay? Or really, yeah, 25 is a successful case. It returns a number that's more or less correct. When you get to factorial 26, it crashes, not crashes, but it returns us an incorrect value for the thing. So it can't go very high before it crashes. So what do we do now inside of factorial? Well, remember, we have a base case. There has to be inside of the method that's going to be called recursively, there has to be an endpoint, because if there's no defined endpoint, it's not going to run properly. So what is our endpoint? That's what you got to think about. What is the case in which this should return something and essentially be done? So our end case is when n equals 1, because we know what 1 factorial is. 1 factorial returns 1, because 1 times essentially itself, well, it's supposed to be 1 times n minus 1, which would be 1 times 0, which is 0, but in the case of mathematics, we've defined it as 1 factorial equals 1. So we know that if n equals 1, we should return return 1. Okay, and because we're returning a long, you might need to put an L in there to say that it's a long. I can't remember if you need to do that or not in terms of making this program work properly, but I'm going to put one L just to say it's a type long. So if n equals 1, then return 1. Okay, that is our base case. So we know so long as we're going to have n converging down to 1, we will and should hit the end base case, and it should always terminate properly. Otherwise, if it's not equal to if n is not equal to 1, what should it do? Well, remember what our formula is. R equals n times n minus 1, right? So we should say, and always remember, whenever you're working with not factorials, whenever you're working with recursive methods, it should always return something. Okay, these methods should always return. You should never just have it say, n equals n minus 1. Okay, because that's not going to return anything, and then it's not going to compile properly. So remember, we always return. So we're going to return n times, that's a bad times, n, no, I was going to say n minus 1, but remember, we need to call itself. We need this to be a recursive method. So return n times factorial of n minus 1. Okay, so this is our n is converging down to our base case. N minus 1 will get closer and closer to being 1 so long as we have a positive n. I don't want to get into negative cases in here. That would break things. But we could say if n is less than 1, then return an error or something like that if you wanted to make this super idiot proof and whatnot. We could also check to see if n is numeric, although that'll do it already at compile time, so that might not be needed. So you see how this is coming along here? I'm sort of running out of room of where I can type. So let me just see if we have any questions that have been asked. It looks like there's still just one question, so that's cool. If you have any questions while I'm going through this, let me know. So now let's go through and actually line by line understand how this algorithm works. So let me sort of block this off. Should I? No, let me block this off into its own little thing. So I'll try my best to, over in this area, to try to take you step by step through how this thing will function. Okay? Because now it's one thing to write a recursive algorithm. It's another thing to understand how recursion works under the covers. So this public static void main string arg is going to be where our program starts. Now, our program starts here, therefore it's going to call factorial, and it's going to pass in the number 5. So n over here is going to be equal to 5, and that's where we're going to start. So we're going to hit factorial 5, it's going to execute this factorial method, and it's going to pass in 5 as our value. So let's start with the first call of this being the first sort of, I almost want to call it a page of information. So we're going to essentially have 5 pages of information, and I'm going to represent a page perhaps like this. Let's do, can I fit 5 down here? Probably not. Can I fit 5 across here? Let's see. 2, how much room do I have? I can go over to about here. So yeah, I can fit one more in there. I know they're, boxes are going down here, but 3, and then maybe 4 and 5. And I know there's 5 sort of pages or boxes ahead of time here because I know that factorial 5 only calls itself 5 times. 1, 2, 3, 4, 5. So there's a bit of, pre-knowledge here that I have to set up these boxes, but that's neither here nor there. So the first step through, we have n is equal to 5. Another way to look at this is saying factorial 5. So I'm just going to call this f for short to represent factorial. Factorial at 5 equals what? Okay, and the same thing here. Since we'd start at 5, it's going to go and it's going to do its thing. Does 5 equal 1? No, it doesn't, so it's going to skip, and it's going to do 5 times factorial at 5 minus 1. So it's going to do n times, or it's going to do 5 times factorial at 4, right? So then factorial at 4 will have to be executed, and we don't know what the result is. And then factorial at 3, because n is always going to be decreasing by 1, right? Minus 1, minus 1, minus 1. Factorial at 2 equals what, and then factorial at 1 equals what. So what's going to happen here is going to say 5, pass in 5. Is 5 equal to 1? No, so it's going to skip that. It's going to say 5 times factorial at 4. So because it's saying times factorial at 4, factorial, where you pass in an integer 4, is defined as a method, right? Factorial 4 is a method. What method is it? It's this one right here. So it's going to call itself recursively, right? And it's going to go in, and now int n is going to be 4, because 5 minus 1 is 4. So it's going to call itself with the number 4, and it's going to pass in 4. Does 4 equal 1? No. So it's going to go here and say return 4 times factorial of 3. So it's going to keep on calling itself. Is 3 equal 1? No. 3 times factorial at 2, call itself. 2 is here. Does 2 equal 1? No. 2 times factorial at 1, call itself. 1. Does 1 equal 1? Yes, it does. So it's going to return 1. Okay, so here's the base case. Here's the case in which this terminates. So it's going to return 1, which means factorial at 1 now equals 1. Okay, so we've done this part. Done. Fantastic. So now what it does is, since we're returning, returning right here, since we are returning, this page is done. So kind of in the call stack, what you're going to see in the call stack is you will have seen 5 different things in the call stack if you were debugging this, right? You're going to see 5 different, in one thread, you're going to see 5 different lines that all have the same sort of code inside of it. And it's going to be, this one will be the 5th one, and now it'll return. So this return statement, return 1, will sort of be done with that call, that particular part of the call stack. So it'll be done, it'll return 1. But then this is where the magic of recursion comes in. This is where the concept of not knowing, or the confusion when it comes to recursion comes. So the confusion is, well, what's going to happen now? It's returning 1, but what happens with my code? Well, what happens is, it's going to go back to the previous thing, the previous call stack element in your entire call stack within your thread. So it's going to go back to this page, essentially what I call it. Okay, it's done this one. It's going to go back to this one where n was equal to 2. So n is equal to 2, which means it comes back to this line. Because if you remember, if you look at your debug, when you're debugging this code, this is where we left off when n was equal to 2, right? We had hit n where n was equal to 2, 2 times factorial of 1, right? This is where we left off. We called this function, which recursively called itself, but now we have an answer for what factorial of 1 is. So it's returning the value of factorial 1 back into this line. So now we have return 2 times factorial of 1 is 1. So what is 2 times 1? We know the answer to that question. 2 times 1 is 2. So this is going to put in 2 here. I should probably do that properly. Where's my little thing to erase? Try my best to erase it somewhat prettily, if that's a word, prettily. 2. So now, because 2 times 1 is 2. So now we're done, right? We just did 2 times 1 equals 2, and we've returned it. So now we are done with that page, right? So what happens when we're done with this page? It goes to the previous page. Where did we leave off in the line of code for the previous page? Well, we were, again, right back to here. We had done 3 times factorial 2. But now we know what factorial 2 equals. Factorial 2 equals 2. So now we have 3 times 2. What is 3 times 2? Well, now we have an answer to 3 times 2. It's no longer a question mark. 3 times 2 is 6. And now we are done with that page of the algorithm, of the recursive algorithm. So now where do we go from here? We go backwards to the last page, the previous one, which was, again, right here where we were doing 4 times factorial 3. What is 4 times factorial 3? Factorial 3 is 6. So what is 4 times 6? It is, what is that, 24? 24. Uh-oh, now I'm going to hit a good one here. I'm going to have to flex my math muscles. Shoot. So we have, okay, so we're done with this one. Focus, Trevor, focus. Stay on target. Star Wars reference. So 24, factorial at 4 equals 24. Where do we go from here? We go backwards to the previous page, which is 5. Where were we when we were doing that? We were on this line of code, n 5 times factorial 4. What is factorial 4? We have an answer for it now. Factorial 4 is 24. So what is 5 times 24? It is 120. I think that's right. Correct me if I'm wrong. 120. So now 5 times 4 is 120, and we return. Where, now that we're done with this one, done with that one, where do we go from here? Where were we before this page? We were right here. This is where we started. Remember, that was our starting point. We started at factorial 5. So now factorial 5 will return the value of 120, because that's what we were trying to find out. And really what I should have done was a system out print line or something like that to output the return result of factorial at 5, but let's just say I did that and it is 120. So therefore we have our answer of 120 will be sent out to, well, it won't do anything right now, but if had we said system out print line, it would have printed it to the console and we could have worked with 120. So there you go. That is how recursion works. And that is, like I said, as long as you follow these 3 specific rules, it needs to call itself, it needs somewhere to start, and it needs a base case in which it can sort of end and go towards, really. That's probably another rule I should put. It should always converge towards the base case. Should have base case and converge. Is it E, I think? Converge towards it? Towards it. Well, I don't know if I have enough room to write towards it. But it must converge, you know, towards, I can point to, you know, in this case it's n, but, or rather it's 1, I should say, right? Because we're trying to converge toward n equal 1. In this case, we're trying to converge towards n equal 1, but in whatever case it is that you're working with, it should converge towards that base case. Okay, really that's what I should say, converge towards the base case. So that is universal. That is a universal concept across all programming languages. That is how recursion works. So the most important and complex thing that you need to remember is how the pages work. So I wish I could do these Facebook Lives with the debugger open in front of you. Maybe I'll do an actual like workshop or something. Maybe I'll do a webinar or something where I cover this topic, because it's really neat to look at the debug call stack and to see, you know, each one of these pages inside of the call stack, because each one of these pages in the call stack have their own local implementation or local settings for the variables, right? Because when you're at f at 1, n equals 1, so the value of n, this variable of n, is equal to 1 in this instance of the factorial method being called. But if you go to this one, even though it's the same code, right? It's the same code, but because of the way recursion works, this part of the code, this page, has a different value of n. So if you're looking here, n is equal to 5. If you're looking here, n is equal to 3. If you're looking here, n is equal to 1. So it kind of is a bit of a mind-blowing thing to see, but it really makes sense as long as you think of it in terms of the fact that these are all essentially different instantiations of the same method, right? So we could rewrite this thing to have it call different names of methods. Instead of, you know, we can have it call it factorial 5, which then calls factorial 4 method, like factorial 4, not n minus 1, but actually type in 4 here, and then redefine factorial 4 below it, and redefine factorial 3 below it, and so on and so forth. And that's essentially what's happening here. It's calling, even though they're called the same thing, Java will be invoking essentially a different instance of that method. It's a new invocation of that method. All right, and that's why we can store different variables and different things in these different in the same method. So hopefully that is as unconfusing as it possibly can be. I know if you're just joining me now and looking, you're seeing all this code and going, what the heck is Trevor talking about? So yeah, I was busy. So you probably have to, if you're just joining me now live, you'll need to go back and rewatch the video. But hopefully this was a very informative video. So Sydney, you'd asked a question. I'm going to answer it now. Hopefully Sydney's still with us. Sydney says, I'm a Java developer too. Awesome. Good for you, Sydney. I always practice algorithms and read a book of frameworks. What is the best routine to be a good programmer? So This has nothing to do with recursion now. All this stuff on the screen or on the board, it has nothing to do with the question that was just asked. So I'm going to remove everything on the board while I answer this question, because I'm at some point going to need to remove all this stuff. So to answer the question, essentially the question is what's the secret to becoming a good programmer is essentially the question that is being asked here. And of course, that is a very good question. So I can give you only my own personal answer to that question. Obviously, I don't hold the absolute secret to becoming the greatest programmer of all time. If I did have that answer, I would be a very rich person. So from my own personal experience, when it comes to being the best that you can be when it comes to programming, it's really two things. The first thing is never stop learning, right? Never stop learning. When I was working full-time as a Java developer, I learned something new almost every day. Now, I learned something new almost every day because I was working full-time for a company that worked in the healthcare field. I was working on the administrative side of the healthcare system in the U.S., mostly in the U.S., some in Canada. But the Canadian rules and the Canadian regulations around healthcare are much simpler than in the U.S., as I'm sure you guys in the U.S. probably already realize. So I was working on the administrative side, so essentially the billing side. So if you were staying in a long-term care facility, so if you had your mom or your dad is fairly old and they need to be in a retirement type facility, a long-term care facility, you would be billed for it, right? You would have to pay every month for your mom or your dad or your parents both being in this sort of long-term care facility. And the rules around how you would have to pay, changed quite dramatically based on each person and their, scenarios in which anyway. So it was a very confusing job. And I learned a lot. And I learned a lot just because I was working in the job. I would learn new things about coding because I was working with other people. So one key takeaway is work with other people. Work with other programmers. If you can work with a programmer that has a lot more experience with you, you are going to learn a lot of stuff. So, pair programming was the greatest thing in the world when I was a programmer. Pair programming is where you sit down with another programmer, you both work on the same problem. Only one programmer at a time will be able to type on the keyboard, okay? And that is the concept of pair programming is one person types, the other person observes and gives their feedback, gives ideas, suggestions, or corrections. If they notice that someone has done something incorrectly, they will correct them. I love pair programming because it's a great way to learn, right? So the first and most important thing is learn something new every day. If you can't be learning something new every day, you're a bit stagnant then. And that's what happened with my job. I got to a point where it had been a whole month and I hadn't tackled any new problems. I hadn't learned anything new at all. I had just been, going through the motions and doing my own thing and being very comfortable in my job. And that was not something that I liked. I'm someone who always wants to be learning something new. So I eventually quit that job. And that's why I'm doing what it is that I'm doing now, because I find when I'm doing what I'm doing now, I learn new stuff all the time. Now, it's not necessarily that I'm learning new stuff about programming every day, but I'm certainly challenging myself to grow as a human being. So my life's purpose is to constantly be learning new things. And that is a great takeaway when it comes to programming. If you want to improve yourself as a programmer, learn something new every day. All right. So how you can go about doing that is, yes, pair programming. Find someone, a mentor, find someone in your job to pair program with. Ask your boss if you can implement pair programming. I cannot stress enough how amazing pair programming was for me and my learning. So learn. If you can't find someone to learn from, of course, there are a myriad of free YouTube videos out there. There's a myriad of courses. Of course, I have a bunch of courses that I sell. If you're interested in one of those, yes, you can ask me about them. I don't want to pitch my courses right now. You have to be learning in some way, shape, or form. Okay? The second of the probably, two ways that I would say how you can improve yourself as a programmer is to build your own stuff. Okay? Solve your own problems. This is what I did. Oh, here we go. I can come back to talking about something I wanted to talk about earlier when I was talking about an old project I worked on with Recursion. So So this all comes full circle. Work on your own projects. Solve your own problems. Come up with a way that you can think of something that you would like to have a solution to that doesn't exist already. Or maybe the solution exists, but it's just not good enough when it comes to the problem that needs to be solved. And come up with your own solution. Program the own solution. Program it with technologies within the programming language that you're using that you're not already familiar with that you want to learn. Okay? This is what I did when I was in, I think it was my first or second year? No, second or third year as a programmer. Excuse me, I'm full of water here. So my second or third year as a programmer, I wanted to learn the Spring framework. At that point, Spring framework was in its first or second version, and the company that I was working for was using Spring, and they didn't ask me to learn it. They didn't require me to learn it. That was not part of my job agreement to understand the Spring framework. I was hired to do some stuff around JSPs and whatnot. I didn't have to know Spring, but I saw that Spring was an emerging technology that was being adopted fairly quickly amongst many programmers as well as companies, right? So it was a growing and more popular framework for creating web applications. So I said, you know what? I want to learn Spring. So what I did is I forced myself to use Spring by working on my own project. And the project that I chose, you can solve your own problem, but the project that I chose was I embarked with a partnership with my college roommate, and I should say previous college roommate, and we worked together to start a company. And the company we started way back when was called Ecosim Software Incorporated, fancy name. And what it did was it provided a solution to people, what are they called, ecologists who are out in the field who need to take down measurements and stuff like that of different areas of land out in the wild. So their solution was to do stuff on pen and paper, and we decided to digitize it, to take them into the 21st century, and so they can do it on their iPad or their notebook or whatever. They can do these things, and it can be stored in a database and so on and so forth. So I did that. We created a web application that helped ecologists with transitioning away from pen and paper and towards technology in order to essentially make everything more, make it cheaper, right? Because they had to write stuff on pen and paper, and then they had to hand it off to a data person who would have to then do data entry and type in all the notes from the person who had written it on pen and paper who was out in the field. So they had to pay essentially for two salaries, one for the person collecting the data, one for the person who was digitizing it. And that whole process, they also had human error that would come into place. So the person doing data entry could make an error, so on and so forth. So we said, hey, let's bring them into the 21st century and build a web application that will solve that problem. And the web app we built, I forced myself to learn Spring because we were using Spring to build that web application. So that is a fantastic way to learn. When you force yourself to use a technology that you want to learn, you have no choice but to use that technology. So that's what I did. I can't recommend that strategy enough. So the two main things are how do you make yourself a better programmer? Always be learning, and practice, practice, practice. Okay, practice with your own assignments. Now to touch on, let me just see, there was another question or something. This is your most liked video yet. Okay, that was Facebook is telling me this is my most liked video yet. So thank you for liking my video. So to take all of that I just talked about and put it back into recursion, because remember I said I want to talk about recursion, for that application, the ecological land classification is what it was called, ELC web app that we created. The web app, there was a part of it that had essentially an area where the ecologists would need to pick data points. So it was like it was classifying the landscape that they were looking at. So there was a whole bunch of really domain-specific, terminologies used to classify a piece of land. I can't remember all the names at this point, but there was essentially 7 different boxes that in each of the boxes had radio buttons, right? So maybe I can draw this out. So there were 7 different boxes. I'm just gonna have to erase all this now, but this is a good way to get my point across about what I'm talking about. I'll just do 4 boxes for now. And in each of the boxes, there were radio buttons that you could choose from. Let's say there's 4 radio buttons that you could choose for each of the boxes. So again, this line of thought that I'm going through here is talking about recursion in the real world. This is how I applied recursion to solve a real world problem. So each of these radio buttons had choices. I don't remember what the choices were anymore. I'm just going to label them with numbers. So 5, 6, 7, 8, 9, 10. I'm going to be working out 11, 12, 13, 14, 15, and 16. Boom. So what would happen was if you selected, let's say, the second option on the first box, you would then not be able to select 5 and 6, and you'd only be able to select 7 and 8. Okay? And then if you selected 8, you would only be able to select, 9, 11, or 12. And then if you selected 12, then you could really only select, maybe just 13 or something. So then you could only select 13. So depending on your root choice, all the other radio buttons changed. So if I had chosen 1 instead of 2, maybe 7 and 8 would be crossed out, and you can only choose 5 or 6, which then you can only choose, 10 or 11, and so on and so forth. So this was naturally a recursive type algorithm that I could use to solve this problem. So it would recursively go back to the start. Remember, there were the 3 things: the start point, an end point, and it had to call itself, and it had to converge towards the end. So this is the start point. The start point was the first box. The end point was the last box. And each of the steps converged towards the last box. So all of my, the rules for recursion were in place here. I had everything set up for it to be a recursive algorithm. And that's what I did. I created it as a recursive algorithm that, if they chose this one, it would go in and it would do some stuff to disable the appropriate radio buttons and enable other ones, and so on and so forth. So it was a really cool algorithm. It was really it was really quite complex. I spent a long time on it. I spent probably 2 weeks on this bloody algorithm. It was pretty intense. And then the end result was the ecologist who was out in the field choosing these options would never make a mistake. They could not make a mistake because all the rules were programmed into this was actually JavaScript at the time. This wasn't even Java. This was a JavaScript. This is a front presentation layer because these are radio buttons and stuff. This is the view. So this was a JavaScript solution where in JavaScript, I had a recursive algorithm. So it was quite cool. I was very proud of it, and sadly that business failed because the size of the market was way too small. So that's a little business lesson for you. Make sure that your size of your market is big enough to make the business viable. So in order that has nothing to do with programming, so we won't need to talk about that. So unfortunately it failed, and the beauty of this recursive algorithm was never really fully realized by a large number of people. So hey, that's the way it goes sometimes. That's the name of the game. So, all right, ladies and gentlemen, I don't have any other questions. I will take the time to say thank you for watching. If you have any questions, please post them now while I'm erasing this stuff. If I have no more questions by the time that I am done erasing, then I will end this little Facebook Live session, this little private chill session with me and you. If you have any questions, let me know, because I'm halfway done erasing, and if you have no questions, then I'm going to end the live chat. I see no more questions. We have 2 more boxes. The questions can be about programming. It can be about your career as a programmer. It can be about anything related to programming. Feel free to ask. But ask quickly. I'm on my last box. If not, then we will just have to wait until the next Facebook Live session that I do. Alrighty, beautiful. There's all these little itty bitty marks that you probably can't see that drive me nuts on the side of the screen. Anyway, all right, I see no more questions, so thanks so much, guys, for joining me. I'm going to sort of duck underneath this fancy light board that I have and come back in front of you. Thanks so much for joining. I guess until next time. And don't forget to check out coderscampus.com. There's some cool stuff I have there in terms of courses and whatnot. If you want to learn more about Java, I have a core Java course. If you want to learn more about enterprise Java and creating web applications, I have enterprise Java course. I have stuff about pretty much every language that you can use inside of the full stack programming environment. So check it out, coderscampus.com. Actually, that's my Coders Campus membership. You can check out professo.com, double F, double S, Professo. Check it out, and you can get in on all those courses. I'm inside of all of them, and I do all the teaching myself personally. So if you like my teaching style, you'll connect with that stuff inside of Professo. So until next time, take care of yourself. As always, happy learning, and bye for now.